All right, everyone, welcome to Connecting Networks. In this week's session, we're going to study Chapter 7 of our NetAcad course, which talks about network evolution. These are the main topics we're going to discuss today. The first main topic we'll be talking about is the Internet of Things, or IoT. After that, we're going to discuss about cloud and virtualization. And the last topic, but not the least important, is network programmability or network programming. Let's go ahead and start with the first topic, which is Internet of Things. It is not new to us that as the internet keeps growing, people just start connecting more and more stuff to the internet. So nowadays people have smart fridges, smart toasters, smart ovens, everything is becoming smart. And what is the consequence of this? Is that people are starting to connect these devices to the internet. So there was a prediction that the internet would be connecting more than 50 billion devices by 2020. So you know that the world's population is around 7 billion people. So that basically means 8 to 9 times more than the world population. That is just basically because we have many devices per every single one of the households that connect to the internet. So in my house, for example, I have at least 10 devices that I connect to the internet. Do you guys have an idea of how many devices you have at your house that connects to the internet?
Um, maybe around that.
Maybe
Maybe
around
10.
10.
Yeah.
Some people, they do have like 20, especially if you have the webcams, the IP cameras, sorry. So the IP cameras, they just basically connect to the internet, and they're just part of the IoT network. You're basically able to access your webcams even if you're not at home. The webcams are connected to a central location, usually an NVR, and then you can access your cameras from anywhere else that you have internet access. But this is the consequence of IoT. So we're basically starting to connect multiple things to the internet. It's just basically about making the world more connected. So you must have heard this before. So the more devices that we want to connect to the internet keeps growing, IoT keeps growing. And as the population keeps growing, people start connecting more and more things. Technology advances, people start connecting more things still. So now even cars are being part of the internet already. So people started connecting cars already. The electric cars, some of them
Yeah.
they actually come with 3G, 4G, 5G technologies that just basically allows them to be connected to the internet 24/7. You're able to access your car through an app and things like that. All right. So that just basically means, guys, you're gonna have a job for the rest of your life, pretty much. Okay. Because I don't see this slowing down at any point in time. Okay. The more we grow as humanity, the more technologies that we develop, the more things we are connecting to the internet. Now, we're also living a time where the networks and the technologies, they are converging. Now, this idea of converged networks is not a new idea. It's actually a pretty old idea. And that was basically based on the fact that you could take advantage of certain technology to carry other types of technologies. So for example, early back in the days, if you wanted to have TV, internet, and telephone services, you basically had to have three separate bills. You had to have three separate companies, every company providing a service. Now, with the converged networks idea, everything started to be converging. Everything started to come together. One company would now be able to provide you services that were telephone services, video services, pretty much everything you needed, TV services at once. All right. So they started converging all the technologies, all the services. They started providing these technologies in the same infrastructure. So if the infrastructure was the same, you could provide more services. That was what the companies were doing. So back in the days when we had the cable television, The cable TV guys, they just found out that they could also send telephone and internet signals through the same coaxial cable that they use for TV services. So you know what they did? They started using it. So they started using the same infrastructure, the same coaxial cables that were already there to carry data, telephone, and TV signals using the same cable. The companies were then able to provide these services and usually at one single bill. So you would pay one amount for the same company and you would get many multiple services.
Is that what they do in the US?
Yes. In the US, coaxial is so famous, man. So pretty much
Yeah.
everything is coaxial in most part of the US, is even nowadays. And they just basically take advantage of the coaxial network to just basically provide multiple services such as data, voice, what else? TV services, many products and services.
You have in Sydney also, they're using a lot of coaxial also.
Yeah. So you guys remember the name of these technology, right? The cable technology is the DOCSIS standard.
Mhm.
So the DOCSIS standard just basically allows us to transfer multiple types of signals in the same coaxial infrastructure. Okay. All right, let's go ahead. Now there's a video that actually basically talks about these that I just told you guys. So it's a very nice video from Cisco. I strongly suggest you to watch the video as well to have a better idea of how IoT works. Now, when we talk about IoT, Cisco actually has a IoT system. It is just made up of 6 pillars. And these 6 pillars, they're just basically the foundation of IoT. So Cisco sees IoT with 6 main foundation pillars. And these foundation pillars are the network connectivity. So in order for you to have these type of services, IoT, you basically need the infrastructure, you need the networks, they need to be up and running, they need to be there for you to have IoT services. Another foundation pillar of the Cisco IoT system is the fog computing. So you've heard about cloud computing. I'm pretty sure you guys are familiar with the concept of cloud computing. We are going to discuss what fogging computing is in just a few slides from now. Another pillar from the Cisco IoT is the security, because of course, if we're going to start connecting devices to the internet, we want to make sure these devices are as secure as possible, because otherwise you'll be vulnerable to attacks. Another pillar of IoT is data analytics. Now with IoT, it comes a drawback, mate. The amount of information that you are sending and receiving. The more devices you plug it in, the more data you are sending and receiving. Okay? So there has to be a way for us to make sense of these data, and that's what data analytics does. We also have management and automation. So of course, if we're connecting stuff to the internet, if we're connecting stuff to network infrastructure, we have to be able to manage this. All right. And because we're connecting multiple devices, there has to be a way for us to manage these devices in a way which is way faster, in a way which is more efficient, and so on. And also, the last pillar in the Cisco IoT system is the application enablement platform. Because after all, we want to connect things to the internet, we want to connect things to our network infrastructure, but we want to be able to manage this easily, usually through an app. So this app would basically allows us to manage the devices as well. So this is just basically what the IoT is made of. This is basically how Cisco sees IoT as a whole. There's one more video for you guys to watch in the end of the lecture. It discusses about IoT pillars. Basically everything we just discussed. Okay, let's get started with the fog computing pillar. So I told you I was going to explain this a little bit better. Now, you know about cloud computing. Cloud computing is just basically a way that you can access resources that are not necessarily in the same physical location as you. For example, you can probably access a server somewhere else, which is cheaper to maintain, and then you can still access the resources in that specific server. Now, the idea of IoT, the idea of cloud computing is that we actually going to have this physical server located somewhere in the internet, and we're just basically able to access the resources. So it's not anything new to you guys, but you remember how you use Azure Labs for any of the courses that you did. So
Yeah.
Azure Labs
it's
is
cloud.
so Azure is a cloud services provider. Okay, they provide cloud services. Now, Azure Labs is one division of the Azure Cloud Solutions. Okay, so Azure Labs is one division of it. So what does that mean is Azure Labs will basically provide us with the physical resources necessary for us to run simulation tools, run virtualization, and so on and so forth. Now, we have no idea where the server is. The server could be in China, could be in Taiwan, it could be anywhere else. Okay? It could be in the United States. It doesn't really matter. But the thing about cloud computing is depending on where the server is, and because of the way that things work, and because you need the internet to reach the server, cloud computing may be slow sometimes because of this, because you're still relying on the infrastructure. So you still need to send information to the server somewhere else. It could be on the other side of the globe, and then the server needs to process the information that you need and then send it back to you in the other side of the globe. So applications that actually require low delay, low latency, they cannot rely on to cloud computing much because it depends on the internet infrastructure, and we cannot guarantee it's going to be optimal. All right. So what is the solution for this? The solution for this is fog computing. Now, fog computing just brings the cloud closer to the user. So that just basically means instead of having a server in the internet, I can have a server in my house, for example. And the server in my house will be doing the processing of data of all my IoT devices in my house. So that when my data is created in my IoT devices, I don't actually need to send it to a server on the other side of the internet. I can actually send it to a central location cloud computing server that could be in my house or closer to me. And then the information, the critical delay information is processed at the cloud computing site and then is sent back to me on the fog computing sector.
Robert,
Yes, Jason?
so for computing and the cloud computing is different.
It's different. Fog computing is going to be closer to the user. Fog computing doesn't necessarily is in the other side of the internet. You know what I'm saying, Jason? So here, for
Yes.
example, in this example, cloud computing, we have our computer, it's connected somewhere in the internet. Somewhere in the internet, we have a server, which could be an Azure Lab server. In order for us to access the resources in the server, we are relying on the internet infrastructure. Yes? We have to send the information, we have to send the data through the internet before we can actually process the data in the server. With fog computing, we bring the server closer to us, and all the central information, all the central processing of data is closer to us. It's in the fog computing site. Okay.
Because let me think about why the Google they want to put many server infrastructure in my country. So I just thinking about why they want to do that.
Because they want to bring the cloud closer to them. They want to bring the cloud, which is just basically all the data center, the infrastructure. They want to bring it closer to them so that they don't need to send the data through the internet to be processed.
They
You get what I
can't
mean?
trust China, man.
Yeah. Do you get what I mean, Jason? Yeah.
Yeah.
Shut up, Curry.
All right.
Yeah, I'm just saying, like, they can't trust China.
Okay, let's talk about the second pillar that we need to discuss, which is the security pillar, mate, because, when we start connecting stuff to the internet, we're just basically vulnerable. All right, because we don't know who else is connected to the internet. It could be anonymous, and you could be hacked at any moment. So we need to worry about how we're going to secure the devices that we start plugging in into the internet. All right, there was actually a nuclear power plant, I think it was in Germany, that was
Yeah.
that was hacked just because they didn't have security in the CCTV system. So their CCTV system was outdated. So that just basically meant it was a vulnerability. Someone actually took hold of the whole internet, the whole network, just by hacking into the IoT devices, into the cameras. Okay. So we need to make sure all these devices, they have the latest updates. We need to make sure they have the latest patches. We need to make sure they are connected to an extra device that will be providing firewall rules, firewall services. We want to make sure we are not going to allow access to people that are not supposed to have access. Okay, we're going to implement AAA for authentication and authorization. We want to implement security as much as possible. Okay, and this is one of the pillars in the IoT as well. And Cisco actually provides a whole range of services for IoT solutions. One of them is the security appliance. Now, the Cisco security appliance will basically implement firewall rules. It can implement IPS, intrusion prevention, intrusion detection as well. These are all the services that a security appliance can provide to us. We also have firepower appliances. Some of the firepower appliances, they verify the traffic, they check the entire traffic that is being sent in and out of the network in order to observe if there's malicious traffic behavior, and then they can just basically block traffic before they reach the end devices. And we also have the Cisco video surveillance cameras. I'll tell you, if there's one product from Cisco which is not that much used in the industry, that would be the video surveillance cameras. There are many other brands. They're much cheaper than Cisco, and that's why I believe the Cisco video surveillance cameras are not that used in the industry. But they still exist.
I think that also Cisco phones are not that much in use because
Yeah,
you have so many different companies that are cheaper and even better than them. So
yeah, definitely.
And open source. Are their cameras open source?
Which cameras? The Cisco?
Mhm.
Yeah. There are many other companies that build cameras as well, that build NVRs and everything else.
I mean, like, are their cameras open source, can be used, like, connected with other network devices that are not Cisco related?
Yes, it's all about the protocols. So the cameras, when you buy a camera, Max, they specify the protocol of the camera. Now, if you buy another camera which is the same protocol, they can be connected to the same NVR, for example. If the NVR has the same protocols, they can be used. It doesn't matter the brand, it just matters what protocol they're using. So it just matters what language they speak, and then you are able to connect them. Doesn't really matter. So you can buy, for example, a Swan NVR, which is the recorder, but you can buy a Hikvision camera. It doesn't matter as long as they have the same protocol. Okay. Okay, cool. Management and automation pillar is one more pillar which is part of the Cisco IoT system. Now, IoT expands the size and diversity of the network to include billions of smart objects, like we already mentioned. Now, each of these objects, they can have a specific function. For example, monitoring the temperature, controlling the temperature, reacting to changes, and so on and so forth. Now, there has to be a way for us to bring automation into the game, because automation would allows us to create a system which will check this information that is collected from IoT devices and basically react in real time and make adjustments to the network in real time. Now, Cisco management and automation products, they can be customized for specific industries to provide enhanced security and control and support. For example, we could have a temperature sensor in a data center network. This temperature sensor will just basically identify if the temperature is too high, and we just basically need to turn on the more powerful air conditioner in order to make sure the servers are up and running safely, we can do that using automation, because we don't want a person to be going there and doing the changes. We wanted to make the changes automatically. And that's what automation will allow us to do. It will allow us to create an algorithm that will react to changes in near to real time. Okay. So instead of a person being there and monitoring the changes, we're going to have sensors being there monitoring the changes. In the background, we have an algorithm, we have an automation tool that will check these data, will check these information that is captured from the sensors, and will make changes in real time. Yeah?
So, Robert,
Yes, Jason?
pilot, what the pilot means? The
Pillar.
real meaning.
It's the foundation. It's the foundation of the IoT. All right, let's move on. There's one more video for you guys to watch. Now, I'm going to tell you something. Cisco loves Linux. And I think most of the industry companies, they love Linux. And one of the reasons why is that because Linux is, most of the Linux versions, they are open source. So people can make changes to them. Linux is light and it can be installed pretty much anywhere. Okay, you don't actually need a powerful hardware to install Linux. And Linux is becoming a very famous operating system, especially in the enterprise side, because people don't want to be paying licenses for pretty much everything they have. So one solution would be using Linux devices. Now, what Cisco has been doing over the years is that Cisco is turning the Cisco iOS, as we know it, to manage the devices, into a Cisco iOS Linux based. So most of the current iOSs, especially the iOS X, iOS XE, they are all built based on Linux platform. So that basically means we're able to use the same commands that we use in Linux in order to manage networking devices. Okay.
Oh, that's cool.
So it's pretty awesome. The latest routers, the latest switches, they will be Linux capable. They interact very well with Linux platforms. They accept the same commands. And that's why it's important for you guys to learn Linux. And that's why you do it when you do your Surf 4 and you actually learn how CentOS works, how the CentOS command works. You actually need to practice with CentOS commands and so on.
Nia.
Yeah, Nia. Okay. If you still don't know what I'm talking about, I will refer to another teacher called Declan, and then you.
Robert,
Yeah.
Robert, the Linux, all the command how we use,
That's just basic what we learned, like basic of the basics.
because I
Permissions and stuff.
So
no,
what you guys learn about Linux is just the very necessary commands for you to survive and for you to say, I can learn more. Okay, it's just the fundamentals of Linux. Navigating through the folders, copying folders, files, creating files with the command line, all those sort of things, upgrading, updating, and doing those sort of things. It's what you guys mostly learn in NIA. Yeah.
okay.
Okay, let's move on to the second part of the lecture. Now we're going to discuss about cloud and virtualization. Now, what is cloud? What is virtualization? So first of all, cloud pretty much only exists because of virtualization. Okay, so virtualization is the fundamental of cloud. Cloud exists because virtualization is just there to allow it to happen. Okay, now I don't have to say much what virtualization is because you guys pretty much know what that is. Virtualization is just basically abstracting the concept of hardware and software. So instead of having one hardware for one operating system, for example, we can have one piece of hardware, one desktop machine, and we can have multiple operating systems installed in that hardware. Okay, so this is just basically abstracting the concept of an operating system, abstracting the concept of a hardware, and just basically creating virtualization. Okay. So cloud exists because we have an infrastructure, we have physical servers. With virtualization, we can take these servers, which are worth hundreds and thousands of dollars, and we can abstract the concept of a server. We can divide the server, and then we can have multiple operating systems running on a server. But don't be fooled, because cloud is not only virtualization. Cloud is made up of many other things as well, including automation. Okay. So when we have cloud, we don't want to be creating the virtual machines manually, because that would be demanding. Okay. So cloud has to be bigger than that. Cloud has to have automation. So we want to create the virtual machines as needed. We want to create the virtual machines automatically, and we're going to do that using automation. Now, when we talk about cloud computing, we actually need to talk about the cloud services providers. Nowadays, we have many. Okay. In the beginning, most of them were just Amazon Web Services, and then it came Microsoft Azure, and then Google Cloud. But nowadays, we have a whole range of cloud services providers, okay, including IBM Cloud, Rackspace, Cisco as well. They all provide cloud services for us. Okay. Now, we also, when we understand about cloud, we need to talk about cloud models, because clouds, they can be public and they can be private. Private clouds, they are created by a private organization. They are not made available to other people. They are only available for the company itself. When we talk about public clouds, these are the cloud service providers that will just basically uh, provide these service to people, provide these service to other companies, and so on and so forth. Now, another thing we need to discuss is the cloud services, because we have many different types of cloud services, including software as a service, platform as a service, and infrastructure as a service. We're going to discuss about every single one of them in a few slides. All right, so there's one more video for you guys to watch about virtualization, so please do watch the video after the lecture to understand a little bit better. Cloud overview. So cloud computing, why is cloud computing become so popular, mate, over the years? Why are people just talking more and more about it? And why it's your objective, if you want to be a network engineer, to learn about these technologies? Because they are being used pretty much everywhere. Okay. Why are they being used everywhere? First of all, because they are a pay as you go. So you only going to pay for the resources that you need. You're only going to be paying the resources that you want. You don't need to buy a $100,000 server and just use whatever you want to use. You don't need to spend this much money in the beginning. You can pretty much rent a percentage of these $100,000 service that is owned by someone else. Okay. So you don't need to buy a $100,000 server to have good capabilities. You can basically pretty much pay some money to Google, for example. They already have these $100,000 services, and then they can just rent you a little bit of their server resources for you to use at the time that you need. If you don't need it anymore, you can just stop paying, and then that's it. Okay. Another advantage of having cloud computing is that you can have virtualization without actually owning the physical resources. You don't need to buy a server to have operating systems up and running. You can just basically rent it from a cloud service provider. You can run the operating system that you need, and then you can return it. You can give them back. Okay, you just stop paying for the service, and that's it. And what is the advantage with this? It reduces the operational cost. You don't actually need to pay anything which is operational. So if there is an issue with the server that you're renting from Google and there is a broken hard drive, you don't need to worry about it. It's Google's problem. Okay. They are the ones that will have to worry about the operational costs. They are the ones that will have to deal with the failures. If a $100,000 server fails, and it dies out of a sudden, Google will have to deal with it. It's not your problem. What they're going to have to do is they're going to have to allocate you another server so that you can still have your services up and running. All right. So this is one more advantage of cloud computing. How about cloud services? Now, cloud services, they are defined by the National Institute of Standards, the NIST. They are basically 4 main cloud computing services. The first one of them is software as a service. So you just basically have the software application, which is running in a server somewhere, and you're just basically paying for you to access the software. You are not paying to access the resource, the physical resource of the server. You're just paying to access what is already running in the server. Okay. Now one example of this is Microsoft Office 365. So you guys know that Microsoft Office 365 allows us to open Microsoft Word documents when we are in a web page. Do you know this?
Yeah.
So basically, this Microsoft Office has to be running in a server somewhere, in a Microsoft server somewhere. Okay. So what we are basically paying when we pay Office 365 subscription, we are paying for a software as a service because this has to be running somewhere else. We are accessing it through a web page, but it has to be running somewhere. Okay. Now, we also do have the platform as a service, or PaaS, which is access to development tools and services used to deliver the applications. So this is just basically more used by developers. So some of the developers, they don't want to be running the code in their own machines. They can run the code in a cloud platform. So how do they do this? They pay for a platform as a service provider. The platform as a service provider will give them the environment that they need to run the code, and that's it. Okay. They don't need to be running the code in their local machines. This makes sense when a company is actually running a code which is highly demanding in hardware and they don't have the necessary resources locally in their local machines. They will play a platform as a service provider so that they can develop the code and they can run the code in the server instead of their machines themselves. Okay. Another cloud service is the infrastructure as a service. Now, the infrastructure as a service will provide access to network equipment, virtualized network services, and network infrastructure. All right, so this is IaaS. It is just basically if you want to have routers, switches, everything on the cloud, we can do it. And that would be part of our infrastructure as a service. We also have the IT as a service, which is just basically IT professional support applications and platforms. So everything related to IT professional support, including the applications, the platforms that are stored on the cloud, that would be IT as a service. Okay, so how about the cloud models? We do have different cloud models. We have the public clouds that we already discussed. These are made available to the general population. The population just needs to pay as they use the resources. So the more resources that you need, the more you pay, and then you get the resources that you need. So they're just made available to the public. Now, the private clouds, they're not just made available to the public, not even if the public pays for it. Okay, it's not available for them. So this is usually done for countries that have the military cloud infrastructure. The military, of course, doesn't want anyone else to have access to the resources except the military personnel. So these solutions, they are not made available to the public. Okay, it's just private. All right. We also do have the hybrid clouds as well, which is just a mix match of these two things. So even if a company has their private infrastructure, but they still want to have something in the cloud, they can just basically create a hybrid cloud solution, which is just basically a mix and match of private solutions and public cloud solutions. They can use a little bit of both. And we also do have the community clouds. community clouds, they are created for an exclusive use or purpose. For example, the healthcare organizations, they maintain a compliant policy and laws using the HIPAA, which is just basically concerned about the health records of citizens. They require special authentication and confidentiality, but they're not necessarily going to be only for a specific company. Many companies, they can get together with a specific purpose. For example, you could have many companies that want to find the cure for cancer, and they want to have the same cloud infrastructure for them to use and run simulation tools and stuff like that. They can create these called the community cloud with a specific purpose. Okay, we also do have the definition of a data center when we talk about clouds. Now, data centers, they're just basically the main fundamental component, physical component of the cloud itself. Now, the cloud itself are the resources that are going to be made available to us. Now, they have to, the physical resources that are necessary to run these services, they need to exist somewhere. And where do they exist? They exist in the data center. The data center is the actual physical location, the physical resources, the physical servers that we have to provide these services. So typically data centers, they store all the information. They have the data storage, they have the hard drives, the huge amount of hard drives that we need to be running the cloud services, and so on and so forth. Now, what I do have in my, this is an example of the data center in my background. It's just basically where we're going to have our servers, our storage, everything running. Okay. Now, these data center servers, they will be providing cloud services. They could be private service, private cloud, public cloud, or even hybrid cloud, doesn't really matter. Okay. But that's the main purpose of the data center. All right, cloud computing, typically off-premise. So when we talk about cloud computing, it's just basically the services that the data centers will be able to provide. Now, services that the data centers provide include cloud computing, high-speed networking, software as a service, network security is also important for data centers, and virtualization, which is one of the core components of data centers. Virtualization, just like we already mentioned, is the foundation of cloud computing. Without virtualization, cloud computing would not be possible. Cloud computing would not exist without virtualization. Cloud computing separates the application from the hardware. There's another term for this, which is the abstraction that we already mentioned. When we abstract the application, when we abstract the software from the hardware, we're basically virtualizing the components. Now, virtualization separates the operating system from the hardware. So we can run multiple operating systems using the same hardware, given that we have the necessary resources. Now, one component as well of cloud computing was the Amazon Elastic Compute Cloud. Now, I'll tell you that one of the first creators of cloud computing was Amazon. Okay, and it's very interesting of how Amazon actually decided to create cloud services. Amazon is huge, guys, so it's not anything new to you guys that Amazon in the US is huge. Jeff Bezos is like the richest person in the world at the moment. He's constantly competing with Elon Musk to be the richest person in the world. Now, Amazon actually created cloud computing just because they had too much resources that were not being used throughout the year. Okay, so you know how Amazon works. You go to Amazon website, you buy certain things, and then they just basically ship the products to you. So when you create the order, when you want to buy something from Amazon, they create the order. The order has to be sent to a server. The server will process the order, will calculate the shipping costs, will see where the stock is for that specific product, and then we'll do everything for you, right? So it's everything automated. Now the thing is, Amazon was selling more during certain specific times of the year. For example, during Black Friday, Amazon receives more orders than anything else. During Black Friday, during Christmas, during this time of the year, Amazon is actually receiving more orders than any other time of the year. But they still needed to have the infrastructure to be able to handle the high demand of products. Okay, so they still needed to buy the servers. But the thing is, when it was not on high demand during these specific times of the year, they would still have the resources there laying around for nothing. Okay, so they found a very clever way to take advantage of this. They created the Amazon cloud computing. So they were not using the resources when they didn't need it. So what were they making? They were making this available to other people with the Amazon Elastic Compute Cloud. So they were just basically charging people for some amount of money. People that needed to have access to the servers, they would have access to the resources because they were not being used at the moment. So they started with this and everything started growing. They started buying more and more servers. They got into the game for real. So they made this part of their business model as well. So nowadays, Amazon makes a whole ton amount of money just by providing cloud computing. Okay. So of course, after Amazon started doing it, everybody started joining the game. So Microsoft joined the game as well with Azure, and then it came Cisco as well. Many other service providers, many other big companies, they started joining the game of cloud computing services. They started doing pretty much the same. Okay. Awesome. So why should we have virtualization in first place? Now, the reason why we have virtualization, mates, is it's going to make our lives easier. Think about this. For every type of service that we want to provide, we need to have a physical server. Okay. And I'll tell you, before virtualization was a thing, let's say back in the 90s or 80s, if you wanted to have a service, you would have to have a server for that specific server. Do you want to have a DHCP server? Okay, you have to buy a physical machine, install the operating system, and then deploy that server as a DHCP server. Okay, do you want to have an Active Directory server? Okay, buy another server, install Active Directory domain services, and then you have an Active Directory server. Do you want to have AAA? Okay, buy a server, a physical machine, install an operating system, and then you have a AAA server. Do you want to have email server? Okay, buy the physical machine, install an operating system, install an email server such as Microsoft Exchange, and then you have a mail server. Do I have to tell you that this is too hard to manage?
No.
If you wanted to manage anything, you would have to connect yourself to the physical machine and then you have to deal with it. And if the machine was broken, congratulations, you have to build the entire new machine. You had to fix the physical machine. So back in the days, this was not useful at all. It wasn't a good idea. Okay, especially for redundancy. If you wanted to have redundancy, you would have to have one extra server, one extra physical machine for every single extra service that you were providing. This was not a good idea, right? So when virtualization was created, it was just this idea of, mate, we have to do something about it. Because think about this. In this example that I'm giving to you, we needed to have one physical machine to be a DHCP server. But at this point, you know that the DHCP server does not consume too much resources, right? So the consequence of this was that you had to buy the physical machine, but you were not using all the resources in the physical machine. So you were wasting all the power capabilities in that specific machine because the machine was not accessing the extra CPU, the extra storage, because it was just a DHCP server. Okay. Now, how about if we find a way to combine all these servers into one physical machine and we start dividing all the resources evenly with the machines? That's when virtualization came into place. Now, virtualization was created with the idea of abstracting these concepts and just basically dividing the resources in a physical machine in a way that it could be divided in different operating systems, in a way that it could be divided into different applications, different services, and so on and so forth. Okay, so nowadays virtualization is one of the core fundamentals of cloud. It's extremely popular around the world. So the more virtualization you guys learn, the better you get in being a network engineer, network administrator. So I strongly suggest you guys to specialize yourself a little bit in virtualization because it's the future, it's the present, and it's gonna be there in many, many years to come. It's not going away anytime soon. So make sure you do it, all right? Now, it's not common nowadays. Yep. Peter?
When you say by specialize, you mean by specific software virtualization or like
Learning as much as you can about it. So learning
Mhm.
all the different types of virtualization capabilities and learning all the different virtualization products. For example, Hyper-V, you guys already know Hyper-V, right?
yeah.
So I'm suggesting that you guys should start learning all the virtualization technologies as well. All the virtualization providers such as VMware. What else? We do have VMware. We have Hyper-V, Bare Metal. We have IO. There is one more that I forgot the name.
There's box or something it's called.
VirtualBox, yeah,
Yeah.
VirtualBox is another
VirtualBox,
one.
yeah.
Yeah. So I'm suggesting you guys that now that you know how virtualization works, you start to explore the other virtualization technologies and virtualization applications. Start to play with this so you learn how to deal with other technologies as well. All right, let's go ahead. One major advantage of virtualization, we are going to spend less money with equipment because now we can install many operating systems in the same physical machine. We are going to consume less energy because we have less equipment. We are going to consume less space, less physical space because we have less physical machines that we need. So there are huge benefits of virtualization. All the benefits of virtualization, easier prototyping. Okay, so it's easier to create a machine and operating system, and then it's easier to delete it if you need to do it. It's easier to re-image a virtual machine and so on. It's faster server provisioning. It's much faster for us to bring a server back online and take a server offline and stuff like that. It's increased server uptime, improved disaster recovery because with virtual machines we can back up the entire virtual machine. All right. So if you back up the entire virtual machine, it's much easier to bring it back live if the first one crashed, for example. And another advantage of virtual machines, legacy support. Okay, we can create a virtual machine with resources of an old physical machine, and we can, for example, install Windows 2000, for example, on a logical virtual machine. All right, abstraction layers. Now, what virtualization allows us to do is basically abstract every single one of the physical resources on a physical machine. So we can abstract the hardware. For example, we can have CPU. Instead of talking about this physical CPU in a virtual machine, we talk about the virtual CPU, the amount of CPU that we are reserving for the virtual machine, the amount of memory that we are reserving for the virtual machine, the virtual memory, and so on and so forth. The disk storage, all right, the hard drive, the virtual hard drive. We basically take the original physical hard drive, we can divide it into many different logical hard drives for the virtual machines. One more thing that the virtualization abstracts the operating system. We can have many different operating systems. It doesn't really matter, okay? They don't even need to be compatible. So in a virtualized machine, I can be running Linux, I can be running Windows, I can be running Windows Server. It doesn't matter. They don't even need to be compatible because they don't even know about each other's existence. Let's put it this way. We can also abstract the services. So in one virtual machine, we could be running a web server. In another virtual machine, we could be running an email server. So we can also abstract the services capabilities of a virtual machine. Now let's talk about the types of hypervisors, the types of virtual machines. So you guys remember that when we talk about virtual machines, we have two types. We have type 1 and type 2. Remember that type 1 hypervisors, they have direct access to the physical resources. These are the type 1 hypervisors. Okay. They have direct access to the resources, and then you allocate the resources to every virtual machine directly from the type 1 hypervisor. Now the type 2 hypervisors, they run on top of an operating system. Okay. Now the disadvantage of type 2 hypervisors is that you need resources for the host machine. You remember this name, host machine? The host machine is the operating system that is going to be running the virtualization software, and then it's going to have the virtual machines running. All right. We have many types of virtual hypervisors type 2, including VMware Workstation, Oracle VirtualBox, VMware Fusion, Hyper-V as well. Okay, the one that we use is a type 2, but we also do have a type 1 Hyper-V as well, especially for server infrastructure. Okay, so how about the type 1 hypervisor? They are also known as bare metal because they have full access to the physical resources of the physical machine. So they are more efficient than the type 2 hypervisors. Cool? Because they have direct access to the resources and because they don't require the host operating system. So you don't need the resources to be running the host operating system. Now, type 1 hypervisors, because they don't have a host operating system for us to control everything, they need to have a management console. So in a type 1 hypervisor, we are going to manage all the virtual machines using a management console and not a host machine like we do in a type 2 hypervisor. The management console provides recovery from hardware failures. So the management console is a way that we can fix the virtual machines that stop working, back up the virtual machines that are running, and so on, and recover the virtual machines that had stopped working. There is one Cisco solution for hypervisor, which is the Unified Computing System, or UCS. It's a hypervisor that Cisco allows us to manage virtual machines. Okay, now let's talk about network virtualization. Now, the same thing that we have with physical machines, physical computers, so far we discussed about servers, a web server, what else? An email server. So we discussed about these servers and we discussed about ways we can virtualize them. Now I'm going to tell you something. There's actually a way that we can virtualize the network services. There's actually a way we can virtualize the functions of a router, the functions of a switch with this thing called the network virtualization. Okay, let's talk about network programming and how it relates to network virtualization and this concept of abstracting network concepts that we know. Cool. Now, back in 2012, when I was doing my internship as a telecom engineer, we were already started talking about SDN. SDN and network programmability as well as controllers. Okay. Now, the standard network infrastructure, the standard relies onto every single one of the devices. So do you have a router? The router will be doing the routing functions. The router needs to behave as a computer as well because the router needs to process information. The router needs to be able to be accessed. We're going to manage the router centrally, so we have to go to the router, connect to the console part of the router, and manage the router. If we have many routers in the organization, we will have to go to every single one of these routers to manage them individually because they operate individually. So there has to be a way for us to maybe centralize all the main functions of all the routers in our organization into one single place. This one single place would be a network controller. The network controller would allows us to control everything in our organization without actually needing to go to every single device and configuring every single device. That would not be feasible, especially if we have 1,000, 2,000 routers in an ISP, for example. So there had to be a way for us to abstract these concepts of the controllers on every single device, which is the control plane, and put into a central place called the controller. Okay. Now, when we do network programmability, when we do this, we just basically rely on to programming because we want to program everything. We want to make sure we can run a line of code, and these line of code can be executed on all the devices at the same time with a loop. Okay, so I can create a loop command that will, for example, change the host name on all the devices I have in my organization at the same time without actually needing to go to every single one of them and changing manually. So network programmability, software-defined networks, the controllers, they will allow us to do exactly this. This is the main topic of what we call nowadays network developers. Okay, so the network developers or network DevOps, they will do exactly this. They will actually develop code to control the networking devices. And because this is more efficient, and because this is much easier, and because this is actually more efficient and quicker, it's becoming the future. Okay, so the future of network engineering is network engineers that also know how to develop and also know how to do coding. So if they know how to do coding, they know how to access multiple devices at the same time with the push of a button. So develop the code to access SSH on many devices using a loop. You can change the configuration on the devices and so on and so forth. Okay.
Rob,
Yes, Mr.
so
Quacker?
are you saying that we have to learn these languages?
If you want to keep making money for the rest of your life, yes.
Okay,
Okay.
that's good.
So if you want to
Oil
keep
is
money,
good.
if you want to keep making money for the rest of your life as a network engineer, yes. Okay.
Okay.
This is going to be
Yes,
the
please.
future. It's already here. Okay. So Cisco already has a certification just for people that know how to do this. It's the Cisco DevNet. It allows us to do exactly this. Manage devices with coding. So we have one computer, we can do the coding. For example, we can do Python. So we run the Python code to modify everything in all the devices that are connected to the network.
On
We currently
NetAcademy,
do
you
this.
have a free Python course.
Yes, so get started. There's a free Python course in NetAcad. In the end of the diploma, if you're still interested in this, I am a DevNet instructor, so I can actually enroll you guys into the DevNet course in NetAcad as well. If you pass this Connecting Networks course, if you pass the final exam on the first time with more than 80%, I'm going to give you the course for free.
Ooh.
Yeah.
Sweet.
So get more than 80% on the final exam for Connecting Networks. I'll give you the course for free. It's going to be worth it. All right. So you'll be able to finish after you finish the diploma. And that's it. All right.
Laku cheat.
Okay. So a network device contains the following planes. So this is how a networking device looks like. It could be a switch. It could be a router. They are all the same. They have different planes. The control plane and the data plane. the control plane is responsible for the brains of the device. Okay, the control plane is basically controlling the main functions of the device. Okay, this is a router. The router has to do routing. It has to be there has to be the capability of routing packets in this device. Okay. Now there has to be a way for the router to talk to other routers using dynamic routing protocols. It has to be embedded in the router as well. So this is all part of the control plane. Okay, it's used to make the decisions. It's used to control the functions of the device. The other plane that we have in the device is the data plane. The data plane is just basically responsible for taking the packets from one interface and putting the packets into another interface. So it's just basically the pathway of the data from the ingress port, the ingress interface to the egress interface, from the input port to the output port. This is where the data will be traveling. This is known as the data plane. Okay, so we do have two planes: control plane, which is responsible for the main functions of the device, and the data plane, which is responsible for taking the actual information, the packets or frames from one interface and putting into another interface. Okay. Now the core functions, the core functionality of the device and what the device can do and cannot do is in the control plane. So what we want to do is we want to abstract the control plane. We want to remove the control plane from the specific device. We're going to put the control plane in a central location, and that's how we're going to have our software defined networks. Okay. Now, these are the software-defined network solutions. Now, SDN is a network architecture that virtualizes the networks. So software-defined networks is mostly the general concept of doing exactly this, taking the control plane out of the device and putting it somewhere else. Now, we do have some vendor solutions for doing this. Cisco has the ACI, or Cisco Application Centric Infrastructure, which is just basically going to allow us to do exactly this. Take the control plane out of the device, putting somewhere else, and then managing the devices in a central location. Okay. We do have some other network virtualization technologies, such as the OpenFlow and OpenStack. They are also elements of the software-defined networks. So how's the SDN architecture? It is just exactly this that we already discussed. OpenFlow is a technology that will allow us to do just this. Take the control plane out of every single device, router switches, and put it somewhere in a specific location. And then it's going to allow us to manage all the devices much easily. SDN architecture. So the SDN controller enables network administrators to manage and dictate how the data plane of virtual switches and routers should handle the network traffic. So in the SDN controller, we are basically going to control all the functionality of the devices, including routers and switches. Now, the SDN controller uses northbound APIs to communicate with the upstream applications. Now, we do have the SDN controller, which is going to control all the devices. It's the central location. Now, we have northbound APIs, which are the APIs that will allow us to control these controller. In other words, to type a command so that the controller will accept the command and then do the thing that we want the controller to do. But we also need the southbound APIs. The southbound APIs, they are the language between the controller and the switches and routers that we will be managing through the use of the controller.
API. Sorry.
Jason?
Yeah, API.
API is applications that we can control. So, for example, if we have a computer and we want to control the computer, if we have an API, we can do that with a code. With one line of code, we can execute a command, for example.
So what's the full name?
Huh?
The full name.
The full name of what?
API.
Definition of API. Like the full acronym.
The full acronym of API, application.
Interface.
Yeah, application programming interface. So
Yeah.
it just basically means that in order for us to access the resources in some place, we have one code, one line of code to do this. Okay. All right, let's go ahead and do the rest. There is one video as well for you guys to watch. It basically discusses about the idea of APIs and things like that. Yep, so this is about the ACI architecture that Cisco has. Now, with the ACI architecture that Cisco has, we do have the application network profile, which is a collection of endpoint groups, the connections and the policies that we define in the controller. We have the application policy infrastructure controller, which is the central location, the brains of the architecture. And we do have the Cisco Nexus 9000, which are all the switches that will be managed by the APIC, or the brains of the ACI architecture. When we're doing the APIC infrastructure and architecture, we just basically need to find a way to connect the APIC devices or APIC devices into all the other devices that will be managed. And usually this is done following the spine leaf topology, which is just basically taking all these brains of the network, which are the Cisco Nexus devices, or it could be somewhere else in the network as well, in a server, that will be managing all the devices. Now, usually this is done through Nexus 9500 switches and the 93 switches. Do you guys remember the hierarchical model? It's similar to the hierarchical model. We do have the devices on top, which is
The core.
it's called the spine, but that is similar to the distribution layer in the hierarchical model. And we do have the leaf, which is similar to the access layer in the hierarchical model. Okay. They just have a different terminology because they are now being managed by an APIC software controller. Okay, we already discussed about this. Yep. Now we talk about the APIC EM. APIC EM is a software that Cisco has for us to manage the APIC infrastructure. Okay, the application-centric infrastructure. So whenever we have the Cisco devices, the Nexus 9500 switches, 9300 switches, the APIC EM is basically a software solution that will allow us to manage these devices. Yep. This is everything that we learned today. The main topics. So we talked about the Internet of Things, cloud computing and virtualization, network programmability, and the necessary need for us to learn about programming and how to abstract the concept of networking and create the controllers. And this is everything we discussed today.
Very hot topic.